now we're ready for part 5 of the lab, and we want to talk about the sign convention. So hopefully you've seen something that looks like this before. So when you took algebra or geometry, do you remember that you had the 4 quadrants to a graph? So you had quadrant 1, quadrant 2, quadrant 3, and then quadrant 4. And the way that we did this, we always put 0 in the middle, and then it was positive numbers going in this direction, and then it was positive numbers going up, and then it was negative numbers going this way, and then negative numbers going that way when you went to graph something. So this is very useful in physics, so that we are going to, when we say that something has a positive velocity, then that means it has a velocity to the this way. And then if it has a negative velocity, it's in that direction. We can do the same thing with the positions. So a negative position means it's on that side of the 0 point. We could also do the same thing with accelerations. So a negative acceleration means it's accelerating in that direction. Okay? So that's what we mean by sign convention. And we use it a lot in physics, the sign convention for it. Okay, so this one is a little bit more complicated one. So your initial position is going to be 0. Your initial velocity is going to be 3. But look here. The acceleration is going to be negative 2. Negative 2. So that's very important that you dial that up on the simulation here. So when we go back to here, make sure and give it a negative acceleration. Pull the slider over here, or I think you can just type it in the box right here, a negative acceleration. And then you're going to calculate the distance that it's going to travel. Now this time I'm not going to tell you, so it's going to be one of these 3 formulas is the one that you're going to want to use. But you need to decide which one to use. So look at this data, and then that's going to narrow down your choices as to which equation to use. So the distance that it's going to travel calculated, and then what is the distance traveled from the simulation. And so again, these 2 numbers should be the same. And then when you do get the distance, you'll notice that the distance has a particular number to it, or it has a particular sign that goes with it. And so what is the significance of the sign of the distance that you calculated? Part 6. So now we're ready to do part 6, and I'll be back in just a moment.